Hey guys, so this video is a review for the first exam of 094. Our first section is 1.1, Simplifying Expressions. And this one is different from all the other sections in the chapter because there's no equal sign or inequalities. So we're not going to get answers like x equals something or x is greater than something. We're just going to get sort of, in these first couple, they're just numerical, so we'll just get a number. But in the later ones, we're just going to get things like 3x plus 7, and we're not going to be able to solve that at all. So you have to kind of recognize this one. The directions are simplify on the test rather than solve. It's a good way to tell them apart. And so first, we'll just kind of start with order of operations, or PEMDAS. Or maybe, please excuse my dear Aunt Sally, whichever version. So we start with the parentheses, and we do the round ones first, and then we go out to the brackets, and then the squiggly ones, which are braces. I'll draw this a little bigger over here. And so innermost, and then we work out. E is for exponents, so we do those second. M and D are multiplication, division. It's not that one beats the other, we just work left to right as we run into it. And then last, A and S are addition and subtraction. Again, work left to right on that. So these first couple, lots of tricky signs here. So this negative in front is just going to stay there because it's not affected by the square. It's just like I have a -1 and then a -3 squared. So this is only working on the stuff in the parentheses. So -3 squared would make a 9, but then it's negative because of the sign in front. So -4, that just stays because it's not worked on this 2. So -2 times -2 or -2 squared would make a +4. And then from there I can go -9, 4 times 4, so that'd be a -16. And then down 9, down another 16 will be -25. For this one, let's see, so we're going to do inside the parentheses first. So -5, 7 minus 9 is going to give me a -2. I'll bring down that 6, and then 2 minus 3 gives me a -1. And so this looks awful, but what it really is just a couple of multiplications. So -5 times -2, that's going to give us a 10. And then -6 times -1 would give us a +6. So before these were subtracting, but the sign has switched to addition. So now we're adding. And then 10 and 6 finally is 16. Okay, so next we have simplifying expressions. So they don't have equal signs, and the last ones are also expressions. These are just algebraic expressions. And so remember, you're not solving for anything. I can't tell you how many times people invent =0 on the test and try to turn it into an equation. So we don't want to do that. We just want to do what's there. So -12, I can't combine anything in those parentheses, so I'm going to distribute the 5 because multiply would come before subtract. So -5 times 2 is going to make a -10x. -5 times -3 will make a +15. Sorry, the beeping will stop very soon. And then here we got our like terms, so I'll combine those. So -12 and +15. So I'll bring down my -10x, then down 12, up 15 will leave us at +3. And then that's as far as you can go. There's no, like I said, inventing an equal sign, just to simplify. For this one, I'll bring down that 4x, -2, I'm going to distribute that through the parentheses, so I'll make a -8, and then negative and negative makes +6x, that's right where the sign error happens. And then the -2 doesn't have anything to do with the 5x, so it just comes down. And then we'll gather our like terms, so 4 and 5, well, 4 and 6 would be 10, plus 5 more for 15x. And then that 8's what's left, so -8. Okay, a couple more expressions. So here I'll distribute, so 5 times x for 5x, 5 times 2 for 10, and then -3 times the 4x, that's a -12x, -3 times -2 for +6. And then from there, I'll just combine it by like terms. So 5 minus 12 will leave me -7x, and then 10 plus 6 will be 16. This next one, so we got that little floating negative out front again. So again, you can just think of that as like a -1 out there that you're going to distribute across. So negative, and basically all it's going to do is going to flip all the signs inside. So instead of positive x, negative 2, I'd have negative x, positive 2, because negative 1 times x, negative 1 times negative 2. And likewise here, the signs end up backwards, so minus 3x and minus 5 plus 6. Like terms, so for x's, it looks like I have minus 4x, and then for the constants, 2 and 6 would be 8, and then minus 5 would leave me plus 3. So then next is section 1.2 and 1.3, the fraction review part. I'm going to do the algebra part all together with 1.4 because it was really kind of all the same stuff. But we did have some fractions in there. I do tend to put these on the test, and they do tend to be one of the more missed questions. So I would encourage you to look over just the basic operations with fractions and be comfortable with those. So these first two are multiplying, dividing, and then we'll have adding and subtracting. For multiplying, dividing, the last thing you want to do is actually multiply anything. It's much easier if you do a little factoring. So 14 I'm going to think of as 7 times 2. 15 I'm going to think of as 3 times 5. And then that's going to be times 20. So I'm going to think of that as a 4 times a 5, just because I'm seeing those 5s coming up. And 49 I'm going to think of it as 7 times 7. And then there's this negative sign, so I'm just going to throw a negative out front there to remind myself my answer is going to be negative. And so then, like I was saying, rather than multiplying stuff, cancel first. And so we can just knock out these 5s now. I can knock out a 7. Downstairs I have 3s and 7s. Upstairs I have 2s and 4s, so nothing's left to cancel. And that now is when I want to multiply. So negative 2 times 4 would be 8. 3 times 7 would leave 21. So here with the divide, the first thing I would do is, one, it's negative divided by negative, so the answer is going to be positive. So I'm going to drop the signs. And then for division, remember you have to rewrite the second fraction as a reciprocal and then multiply. And then from there, I'll just do kind of the same thing I did over here. So kind of looking at the 8 and the 12 coming up, I'm going to write that 12 as, and I could break it all the way down to 2 times 2 times 3, but I can see I'm going to cancel a 4, so I'm going to write it as 4 times 3. I'm going to write this 8 as a 4 times 2, again, kind of in anticipation of canceling those 4s. 55 is 11 times 5. So now I can knock out the 11s, and I can knock out those 4s, and I think that's about it. And I'm left with 2/15. For adding and subtracting, that's where we have to do a little bit more work. This is minus and minus, so when I go down here to just kind of get it set up, the first thing I would do is call that plus. And then I need to find a common denominator between 10 and 6. And if you can see that's 30, that's totally cool. You can go straight there. A couple of ways of doing it, or just one way of doing it. One is just kind of look at it and play with it till you get it. 10 is a 2 times a 5. 6 is a 2 times a 3. And so if I want these to have the same stuff, I can kind of look at it as this 2 times 5 is going to need that 3 over there because this one has a 3 and this doesn't. Likewise, the 2 times 3 is going to need a 5 because this has a 5 and that doesn't. And if you just put those together, 5 times 2 times 3, that's your 30. So what I'll do down here is this would need a 5 over 5 to bring it up to 30. And this would need a 3 over 3. So that's going to make 21 30ths plus 5 30ths. And then 21 and 5 will make 26 30ths. And then be careful there to do the last step, which is kind of what we did up here, the factor cancel. So I can see there's 2's going on, so I'll show this as 2 times 13 over 2 times 15. And then I can knock out those 2's, and then 13/15 would be my answer. And for this one, we got negative 2/15 plus 1/9. What kind of stands out here to me is the 15, that's a 3 times a 5. The 9 is a couple of 3's. So if I want these to be the same, this is going to need one more 3, or this is going to need one more 5. So in other words, my LCD would be 3 times 3 times 5. And that would be 9 times 5, or 45. So this one needs 5s, because that's the pair of 3s. And the 3 and the 5 need one more 3. And then that brings us both to 45. So now we got negative 6 45ths plus 5 45ths. And so negative 6 plus 5 makes negative 1 45ths. Okay, so this next round is 1.2 through 1.4 kind of mixed together. 1.2 was addition property, 1.3 was multiplication property, and then 1.4 uses both of those in combination. So they're all kind of the same problem. So this one, let me rewrite it down here a little bit bigger. And so this is kind of emphasizing 1.3 multiplication property. Right now I have an x divided by 4, so multiplication and division undo each other. So if I want to undo this dividing 4, then I multiply both sides by 4. It's probably better to think of it as 4 over 1 when you got the fractions going. So now my 4's cancel, my x is by itself. And then over here I can actually go 4 goes into 4 once and 4 goes into 8 twice, and skip the reducing step. Or you could put it together and reduce, but that's a little bit easier if you can spot it there. So this will be negative 7 times 1, so negative 7 over 2 times 1, so 2. So negative 7 halves. For this one, let's see, we got negative 5 2/5, sorry, and negative 16 15ths. So again, I'm going to use the reciprocal. So that would be negative 5 over 2. And we'll multiply by the same sign so that this comes out positive. And then same over here, negative 5 over 2. So that just becomes 10 over 10, which is 1, so we get x. Here, I think I'll write it out just so it doesn't get, I'm just going to do it. So what I would probably do is, I can kind of see how it's going to cancel. So I could do a 2 out of the 16 and the 2, and a 5 out of the 15 and a 3. So I'll go 2 goes into 2 once, 2 goes into 16 8 times, and then 5 goes into 5 once, and 5 goes into 15 3 times. And then I have that double negative, minus and minus, that's going to make it positive, and I'm left with 8 times 1, 3 times 1. So that would be 8 thirds. Okay, so for number 13, we got more equations. And again, equations have equal signs, so that's how we know we're solving. So here, nothing to combine in the parentheses, so I'll distribute. So that's going to leave me 13, and then negative 3 times 2, negative 6x, double negative, so plus 15 equals negative 5. And then I'm going to, our steps on this are to, actually, let me grab my notes over here and I'll just show you where they are in the notes. So we're going to clear the parentheses first and then clear fractions. Sometimes I reverse that depending on what I have, and I'll show you that in a minute. So we want to, step 3 is collect terms on each side of the equal sign. And I have really do this because almost all the mistakes are made when people try to move stuff left and right. And so if you kind of consolidate as much as you can first, you'll make fewer errors. And then step 4 is addition property, step 5 is multiplication property. And so basically step 3 is section 1.1, step 4 is section 1.2, and step 5 is 1.3. So how that looks here is the first thing I do is clear the parentheses, and now I'm at the collect everything I can on one side or the other. So that's going to make minus 6x. 13 and 15 will be a 28 equals negative 5. So then the next step after that is to use the addition or subtraction property. So we're going to get that 28 out of there. So I'm going to subtract 28 on both sides. And so it's going to leave me negative 6x equals negative 33. And then I'll divide over this negative 6. And that's our last step, which is use multiplication property. So in this case, we have multiply, so we divide. and then x equals, so minus and minus is going to make that be a plus, and then to get this all the way right, we do have to see that there's a 3 that will cancel. So I'm thinking of it as a 3 times an 11 and a 3 times a 2. So reducing out the 3's and I get 11 halves. This one is pretty similar. There's this minus in front that does sometimes get folks. So that's going to look like a negative 3x. And then this minus is that flips these signs again. So now it's going to be a plus 2x and a plus 5 equals 7. So negative 3x plus 2x would leave negative x plus 5 equals 7. So I've cleared my parentheses. I've collected my terms. So now I want to add or subtract. So I'm going to subtract that 5 over. And that gets me negative x equals 2. And then the multiply or divide on this one would be basically just multiplying both sides by negative 1 to get the sign over on the other side. And not something you have to show, but that's what I'm doing to make it come out negative 2. Okay, and then a few more equations. They're just a little bit bigger. So we'll clear our parentheses first. So negative 6x negative 2 equals negative 5 times 4 will be a negative 20, negative negative, so positive 5x, and plus 3. A couple like terms over here, so I'm going to go ahead and put those together. I'll put the 5x first, and then down 20 up 3 would leave me at minus 17. I can solve either direction. I'm just going to arbitrarily solve to the left. So I'll bring my x's over here. If I wanted more positive numbers, I could totally go the other direction too. And then that's going to leave me negative 11x minus 2. That's gone, equals negative 17. And now I still need to add and subtract some more because I haven't finished isolating x. So this time we have to do it twice. So plus 2, plus 2. If you've gotten good at this, you're welcome to do this all in one step also. But I'm just showing all the steps as lots of people are new to it. So negative 11x, and that makes a negative 15. And now we're down to our divide step. So I'll divide over the negative 11. And here there's nothing common between them. So it'll just be, but it is a double negative. So simplest form would be 15 elevenths. So number 16 here, this is a great one to just kind of look at it and go, so that minus is just going to flip all these signs and not think of it as 6 separate multiplications. If you just realize minus is going to make this minus and that plus, it really kind of speeds up the writing it all out because you're really just flipping all the signs. And so you can kind of look and see how I did that. Plus minus, minus plus, plus minus, minus plus, minus plus, and then plus minus. So it just makes everything opposite. And then I'll collect my terms. So negative 3x plus x, that's negative 2x. Plus 4 minus 4, that's cool, those are gone. And then over here I have 3x, and then 7 and minus 5, so that's going to be a plus 2. And then I'm just going to subtract the 3x over and get my x's on one side. And that gives me negative 5x equals 2. And then lastly, I'll divide over the negative 5x, the negative 5. And this is okay. A little bit better way to write the answer is either as negative 2/5 or negative 2/5. Okay, so now we're entering the region of fractions. So we've seen a few different styles, so let me kind of show you how to approach. I got sort of one each of the different styles going. And we've seen it in a bunch of places we can clear fractions, and sometimes that's advantageous, sometimes it isn't. So looking at number 17, this is one where it wouldn't actually be advantageous because this 4 in the denominator goes into both the 16 and the 12. So if I just multiply that through, it's going to clear itself. And so let me show what that would look like. So you can kind of think of these as over 1. So this would be 16x over 4 minus 12 over 4 equals, and this doesn't have anything to do on the other side of the equal sign, so just negative 7. And then here's why I didn't bother to clear, is because 4 goes into 16, so this is really 4x. 12 over 4, that's really just a 3 equals negative 7. And then from there, I can do the regular old solve. So add 3 to both sides. And that's going to get me 4x equals negative 4. And then I can divide the 4 over. And x equals negative 1. So that one, because the 4 goes in, no reason. You could have also multiplied both sides by 4. That would have made this a 1 and this a negative 28 and solved it from there. That would have been also would have worked, but we didn't have to clear the fractions because they were going to clear themselves. On this one, I would wait to clear the fraction until, because I can do a little bit of math first. So if I just bring that 6 over first, that isolates the fraction, and then that's going to let me just do the reciprocal on both sides like we saw in, that was section 1.3. So 3/5 x equals 21. And I can think of that as 21 over 1 if it's helpful, which I think it will be. So I'll multiply both sides of this by 5/3. And that all cancels, and I got my x. And then over here, I could do 105 over 3, but maybe it's easier if I go 3 goes into 3 once, 3 goes into 21 7 times, and then I don't have to worry about catching that reduction on the next step. So 7 times 5 would make this be 35. Okay, this is the last of 1.4. I'm going to rewrite this one down here a little bit bigger. And here's a really good place to clear the fractions, because this is going to be just kind of a pain otherwise. So 4, 12, and 2 all go into 12. So what I want to do is multiply both sides by the LCD. And then what that's going to do is knock out all these denominators. So let's see if we can do this in one step. I should write it out. So what this would look like is negative 3 times 12 over 4 plus 5 times 12 over 12 with the x equals 12 over 2. So that's just showing with all the 12s there. Ideally at this point you're getting where you can kind of do that in your head. So what that would look like, and if this is still good for you, then go ahead and do this. That's no troubles. But if you're like, I can kind of see it, that's cool too. So that would look like 4 goes into 12 3 times. 3 times negative 3 would leave negative 9. And same here, 4 goes into 12 3 times, and there's the same 9. Here I would just think of the 12s canceling, leaving 5x. There's the same thing. And then here, 2 goes into 12 6 times. Same thing right there. So if you can just get the fractions cleared, it's actually a pretty easy problem usually. The trick is just kind of getting out of those fractions. So I'll add the 9 over. And that's going to go 5x, 6 and 9 makes 15. And then divide out the 5. And we end up at x equals 3. And then this next one, so here, notice the 5 doesn't go in, nor there's the 3. So let me rewrite that down here. And leave a little space there on purpose. So what I'm going to do is I'm going to use the LCD before I run it through, just because, oops, I need a parenthesis right there. It's much easier to run through a whole number than the fraction, and then you get fractions everywhere and it looks bad. So if I do it right now, it'll just be a little bit simpler. 5 and 3 would be a 15. So what I'm doing is I'm multiplying both sides right here by 15. So the 15 multiplies the 1/5, which would make 15 over 5, or 3. And then that 3 is going to in turn multiply through the parentheses. So 15 over 3, that would leave me a 5 out front, which is going to multiply this stuff. So again, no more fractions right after the first step, so definitely an advantage. Clearing my parentheses, I'm going to have 6x minus 12 and 5x plus 40. And I'll bring the 5x over. And that's going to leave x minus 12 equals 40. And then lastly, I'll add the 12. And we got x equals 52. Okay, and that gets us out of section 1.4 and on to section 1.5. So this was formulas, and this is where we have more than one variable and we're asked to solve for a particular variable. So for, I think, all of the, no, for most of these we're solving for y. So here the y is right there. So what I want to do is take 5x off of both sides. So that's going to look like 2y equals, and you could write 10 minus 5x or minus 5x plus 10. Either one is right. And then from there, we just need to finish getting y by itself, so we'll divide over this 2. And for right now, this is a perfectly fine place to stop. That answer is totally correct, and we get you full credit. I always worry that people try to make it a little bit better, and they go 2 into 10 and make this a 5. If you're going to do that, you have to be careful. The 2 belongs to the negative 5 as much as it does to the 10. So the real reduced answer would be negative 5 halves x plus 5. I would suggest leaving it right there for right now, but if not, this is where you would need to go. And again, the order doesn't matter. So as long as it's a negative 5 and a positive 10, you're all good. This one we're solving for y. So I could just add the 5 over, but that doesn't take care of the parentheses. So let me do those first. So 1/3 x is just 1/3 x, and 1/3 of 6 is going to leave a minus 2. And now that gives me something I can actually add the 5 to. So add the 5 on both sides. And y equals 1/3 x plus 3. Okay, and this next one is solving for y. It's basically the same problem as the first one. So what I'm going to do is subtract the ax over. So that's going to leave me by equals, and again, I could write it c minus ax or minus ax plus c, either direction. And then from there, I just have to divide by b. So that's going to leave y equals negative ax plus c over b. And this last one is solve for x. So we have y equals mx plus b. And so I will subtract the b over, because I'm shooting for this x. So that's going to be y minus b equals mx. And then divide both sides by m to finish getting x by itself. Those cancel. So that'd be your answer. Okay, so this next section, actually the next 2 sections, are all those application problems. And so this is where I do kind of like making the little table or the list. I find it helpful for just sort of organizing. So for number 25, we got Kevin is 4 times as old as Madeline. 7 years from now, the sum of their ages will be 49. How old are they now? So right now we got Kevin and Madeline. And let's see, so we're going to do a column for now and a column for 7 years from now. So right now Kevin is 4 times as old as Madeline, so we'll let Madeline be x and we'll let Kevin be 4x. And then in 7 years, they're both just going to be 7 years older. So this is going to be x plus 7, and this is going to be 4x plus 7. And then if you remember down here, it's 7 years from now, the sum of their ages will be 49. So the sum of their ages. So in 7 years, you'd have Madeline is x plus 7, and we'd have Kevin is 4x plus 7, and that equals 49. And so the directions up here are set up an equation and solve for full credit. I don't know if I need to say set up a valid equation, but it needs to be an actual equation that has to do with what's going on here. So if you're just going to kind of like guess and check to get the answers, that won't actually get you any credit. So just sort of be forewarned. So once we got the equation, though, this isn't too bad because we just go x and 4x, that makes 5x, and 7 and 7 for 14 makes 49. And then from there, I'll just subtract the 14 over. And it's going to go 5x equals 35, and then dividing 5 on both sides, and I get x equals 7. So x was Madeline, so Madeline is 7, and then Kevin is 4x, so that's 4 times 7, or 28. And make sure once you get down here, make sure to go back and grab that other answer. Next we got Gavin is 5 years older than Quinn. In 11 years, the sum of their ages will be 29. Find the age of each person now. So we're going to have Gavin, we're going to have Quinn, and we have now, and we have 11 years. And then I didn't do one that was ago, but if it was 11 years ago, we'd have minus 11, right? So 11 years from now plus 11 years ago minus. For now, Gavin's 5 years older than Quinn, so we're going to let Quinn equal x. And then the last one was 4 times x, because Kevin was 4 times as old. This one is 5 years older, so this is x plus 5. And then in 11 years, that's going to be x plus 5 plus 11, and Quinn would be x plus 11. If I want to clean that up a little bit, x plus 16. So in 11 years, the sum of their ages will be 29. So that's these two right here. So we got Quinn plus Gavin equals 29. So x and x is 2x. 11 and 16 would be 27 equals 29. And then from there we just do our same old solve. So subtract 27 on both sides and get 2x equals 2, and then divide out the 2. And x equals 1. So that means Quinn, who was x, equals 1. And then Gavin equals 1 plus 5, or x plus 5, which would be 6. Number 27, we have one side of the triangle is twice the shortest. The third side is 6 feet more than the shortest. Perimeter is 86. Find all 3 sides. Recall P equals the sum of the sides. So for anything that requires a geometry formula, I'll have whatever I have in the notes, in this case kind of the reminder that you just have to add it, would also be on the test. So you don't have to worry about memorizing geometry formulas. So we have a short side, and then we have kind of a second side and a third side. So the short side, everything goes blah, 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 short side, blah, 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 short side. So we want to make the short side our x because everything's being given relative to it. So then one side, or I'll call it the second side of the triangle, is twice the shortest. So that's going to be 2x. Third side is 6 feet more than the shortest. So that's going to be x, and then plus another 6. I like making this list because everyone forgets the short side when they go to set up the equation. So our short side plus our second side plus our third side is going to make the perimeter of 86. And again, this is about half the credit for the problem. Once you get this, the rest is pretty okay because it's just collecting terms and doing that solve. So I got 1, 2, 3, 4 x's. So remember there's invisible ones right here. And then plus 6 makes 86. Take the 6 over to the other side. And we're going to get 4x equals 80. And then divide both sides by 4. Not 40. Don't know where that came from. And so then x equals 20. So that means my short side is going to be 20. The second side will be 2 times 20 or 40. And the third side would be 20 plus 6 or 26. Number 28, the length of a rectangle is 5 more than twice the width. Okay, so if we had the length and the width, I'm going to call the width x, and then the length is 5 more than twice the width. So that would be twice the width, 2x, and then 5 more than that. So plus 5. Perimeter is 58, and then recall perimeter equals 2 lengths plus 2 widths. So I'm going to go 2 lengths right there, plus 2 widths, which is my x. There's L and there's W. And I'm going to throw the 58 on the other side just because it looks nicer. And then I'll distribute this 2 across. That's going to give me 4x plus 10 plus 2x equals 58. 4x and 2x, that's going to be 6x plus 10 makes 58. And then we subtract over our 10. And then divide out the 6. And we get x equals 8, so that's our width. So W equals 8. And then length equals 2 times that plus 5. So 2 times 8 plus 5, which would be 16 and 5. So the length should be 21. And then we had the coin problems. So Chris has $3.70 in nickels and dimes. If he has 11 more nickels and dimes, how many of each kind of coin does he have? So we're going to let dimes be x. And he has 11 more nickels than dimes. So nickels are going to be x plus 11. And then we know they're worth $3.70. So I can either do this whole thing with or without decimals. I'm going to pick without decimals because I think it's easier. So what I want to do is I want to go 5 cents times the number of nickels plus 10 cents times the number of dimes, which is our x. And then that's going to equal, instead of 3.70, it's going to equal 370. So I could have done 0.05 and then 0.10 and left the decimal there, or cleared them all. I think it's easier this way. So now we just have to solve. So 5x plus 55 plus 10x equals 370. I got a couple like terms, so we'll put those together. 15x plus 55 equals 370. I'm going to take the 55 over. And 15x equals 315. And then just divide both sides by 15. And should get x equals 21. So that was our dimes. So dimes equals 21. And the nickels equals 21 plus 11. So that would be 32 nickels. And pretty easy one to check because you can just go 5 cents times that, 10 cents times that, add them together, and it should make that 370. Okay, 1.7 was more application problems. So this one goes, the sum of 3 consecutive odd integers is negative 87. Find the numbers. So remember, if it's consecutive integers, you're going to have x plus 1, x plus 2, because that's just counting by ones. So that's just for consecutive. Even or odd, doesn't matter which one, you're counting by twos. So it's going to go x plus 2, x plus 4. So like 1 plus 2 would make 3, 1 plus 4 would make 5, 1, 3, 5. Or if I start on 2, it goes 2, this could be 4, and then 6. So even or odd, you're still counting by twos. It's just a matter, are you starting on an even or an odd? So this one was the sum of 3 consecutive odd integers, so we're doing this. So x plus, and it's the sum, so we're adding. x plus 2 plus x plus 4 makes negative 87. And then we combine up our like terms. So I got 1, 2, 3 x's plus looks like 6 equals negative 87. And we're back to that exact same solve we've done a bunch of times now. So minus 6, and that gets us 3x equals negative 93, and then divide the 3 on both sides. That drops out, and we have x equals negative 31. So you gotta be a little bit careful on the negative ones. So if x is negative 31, then x plus 2, when you add 2 on, you get negative 29 because you're going to the right, right? So it's easy to go 31, 33, 35 because that's what it does on the positive side. But now we're still counting to the right, but that's going to make these be 29 and then 27 negative. Okay, and then we have a couple of interest problems. So suppose you invest money in 2 accounts. One account pays 7% annual interest, whereas the other pays 9%. If you have 4,000 more invested at 9% than you do at 7%. So let's do 7% here. Oops, make that sort of not a percent. So 7%, that's going to equal our x. And then 9%, that's going to equal 4,000 more invested at 9. So that's going to be x plus 4,000. And then our total interest is $840. So we want to go our interest rate times our money plus our other interest rate times our other money, and that should get us our total interest for the year. So here we are going to have decimals, 0.0. So when we have a percentage, we have to change to decimal to do math with it. So 7% of x plus 9% of x plus 4,000. And that's going to equal our interest. So this is our first payment, interest payment, our second interest payment from each account. And that's our $840. Distributing the 0.09 through, 0.07x plus 0.09x, and then 9 times that would be 360 equals 840. I'm going to add these together because they're like terms. So 7 cents and 9 cents, I just think of that as 16 cents plus 360 equals 840. I can take this 360 over. So I have 0.016x equals, that's 480. And then I want to divide out the 0.16. And then that's going to get me x equals 3,000. And I have 4,000 more at 9%, so that's my at 7. Not very good at 7%. So then my x plus 4,000, that's going to be 7 grand at 9%. Okay, one more interest one. So a woman has money in 3 accounts. The rates are 6, 8, and 10%. So do 6%, 8%, 10%. If she has 3 times as much invested at 8 as she does at 6, so I'm going to let 6 equal x, and then 3 times that would be the 8% amount, and then 5 times as much at 10% as she does at 6, so that'll be a 5x. And the total interest for the year is $2,400. How much does she have invested at each rate? So that's going to get us 0.06 times x, and then 0.08 times the 3x, plus 0.10 times the 5x, and that makes 2,400. So 0.06x and that is 0.24x, and then 5 times 10 would be 0.50. And then these are all like terms, so I'll just collect those. So if I think of it as money, 6 cents and 24 cents would be 30, plus 50 would make 80. So this would be 0.80x equals 2400, and then we can divide over the 0.08. Sorry, I think I said 0.80. And we get x equals 3000. So if this x up here is 3000, then 3 times 3000 would make this one 9000, and 5 times 3000 would make this one 15 grand. Okay, and then the last of the story problems, we got triangles. And so one angle of a triangle measures 20 degrees more than the smallest, while the third angle is twice the smallest. So again, we're going to have kind of a small second angle, third angle. So the small one, I'm going to let be x. One angle measures 20 degrees more, so that one's going to be x plus 20. And then the third angle is twice as small, so that's going to be 2x. So it's very similar to the sides, it's just the angles. Find the measure of each angle, and then recall the sum of the angles is 180. So again, that would be given on the test. So we're just going to do x plus 20 plus 2x equals 180. So 1, 2, 3, 4 x's plus 20 equals 180. Bring that 20 over. And we're going to get 4x equals 160, and then dividing the 4 on both sides, x equals 40. So if that's my first angle, 40 plus 20 would be my second angle, and that would be 60. And then 2 times 40, that would be 80 for my third angle. Okay, last of the story problems. In a right triangle, one of the acute angles is twice as large as the other acute angle. Find the measure of the two acute angles. Recall the sum of the angles is 180. So a right triangle, that means you have a 90 degree. And the acute angles, even if you don't know what that means, it's these angles that are smaller than 90 up here and here. So we know that this angle is 90, and then one of the acute angles is twice as large as the other. So if this one was x right here, this would have to be 2x. So this is just 90 plus x plus 2x makes 180. Or you could have said, since this is 90, 2x plus x has to make 90. So 90 plus 3x equals 180. And we bring the 90 over. And 3x equals 90, and then dividing out the 3, x equals 30. So if this angle is 30, and this one's twice as big, it must be 60. Okay, section 1.8. This was linear inequalities, and so we got greater thans and less thans, and greater thans and equals to. Remember that, so open dots go with the ones that don't have equals. That's how we say the endpoint isn't included. And then solid dots go with the ones that do have an equal sign. Most of the math in this section is the same as 1.4. It's just now we have this greater than less than. There is one important exception to that, and that is when you multiply or divide by a negative number, you need to reverse the direction of the inequality, right? So when I multiply or divide by a negative, it flips the inequality, and we just have to remember that. It's usually right at the last step on the problem. So solve the inequality and then graph the solution on a number line. So this one, let me bring it down so I can get at it a little bit better. I got this fraction out front, so what I'm going to do is I'm just going to multiply by the reciprocal, same as what we did in 1.3. I can think of that 15 as 15 over 1. Just one more parenthesis. So this is going to all cancel, leave me just x. And then this is going to go, oops, I didn't actually do the reciprocal. That's kind of funny. Sorry about that. This should be 2/5. This is going to be a really messy 2/5 over here. There we go. About an hour into these videos and I kind of start losing my focus a little. Sorry about that. So now that this actually cancels, and then let me rewrite that up here just so you can see it a little bit better. So here's what it's supposed to say. And so we can just go 5 goes into 15, 3, and 3 times 2 is 6. And then notice I did just multiply by a negative, so I almost missed it, but I have to flip the direction of that inequality. And then that's going to give me a 6. I think on the tests I usually do a number line on there for you. If I didn't, this is as much as I'm looking for. You can declare something to be 6. I may have one like this on there that's already kind of set up. If I don't, you don't have to draw like out to 6. You can just call that middle part 6, and then x's are greater than or equal to 6, so we're going to use a, change colors, a solid dot, and heading forever that way. This next one, let's get the 10 moved over. I'll bring it up here. So that's going to give me negative x over 3 is greater than 2. I'm going to multiply both sides by negative 3 to undo that division by 3. And then again, right there, I just multiplied by a negative, so I just have to be cognizant to flip the inequality. And we get x is less than negative 6. So if I make that negative 6, x less than negative 6 will make an open hole that's really clearly not colored in. So I know that you knew. And it's going to go less than, so heading to negative infinity. Okay, so then we got some parentheses, so we'll clear those. 7 times 3 is 21. 7 times 5, that's going to be a negative 35x. And then greater than or equal to negative 14. I'm going to bring that 21 over. So negative 21 on both sides. And it's going to leave me negative 35x greater than or equal to, so I subtracted, so that doesn't flip the sign, negative 35. But now I'm actually going to divide by a negative, and that does flip the sign. So negative 35 on both sides. And that gets us to x is less than or equal to 1. And so, there's 1, solid, and then less than, so going that way. And number 38, we're going to add that 4 over and get it down to just the fraction. So that will be negative 5/2 x is less than or equal to 10. And then from there, we're just going to multiply both sides by the reciprocal. And that's going to do negative 2 over 5 and negative 2 over 5. So similar to that problem a couple of problems ago. And this is just negative 10 over 10, so that all cancels. We've got x. Yet again, I multiplied by a negative, so once again, I am flipping the direction of the inequality. 5 goes in 10 twice, and 2 times negative 2 will be a negative 4. So there's negative 4, solid dot because of the equals, and x is greater than that. So we're going this way. Okay, number 39, we got fractions. So let me rewrite those just a little bigger so you can see the clear a little bit easier. So negative 1/2 x plus 1/3 less than or equal to 7/12. And then what I'm going to do is multiply both sides by 12 because that's the LCD for everything. Careful not to do one side by 6 and one side by 12. So same thing both sides. And this one's pretty friendly with those ones, so I'll just kind of clear it in place. 2 goes into 12 6 times, so this will be negative 6x. 3 goes into 12 4 times, so plus 4, less than or equal to, the 12s cancel, and that will be 7. And then we're down to our regular solve. So subtract 4 on both sides, and get negative 6x is less than or equal to 3, and then divide both sides by negative 6. And x is less than or equal to negative 1/2. So in that case, in case I did provide a number line, if this is 0 and this is negative 1, it would be right there. And x is, oops, you know what? I'd say if you do enough of these in a row, you forget one. I did divide by a negative, so I needed to flip that. And x is greater than the 1/2, or negative 1/2, so it's going this way. And then number 40 is just kind of a bigger version of the same thing. So 8 plus 2x, and then that will make a negative 6, less than negative 4x minus 10. And then let's combine terms first. So 2x, 8 minus 6 will be plus 2, less than 4x minus 10. I am going to bring my 4x this way. Definitely when I do inequalities, I like solving to the left. I just think they look really funny the other direction. So plus 4x. And this is 6x plus 2 less than negative 10. And then subtract over the 2. And then finally divide the 6. And for once I'm dividing by a positive, so no flip. X is less than negative 2. So there's negative 2, open dot, and less than, so going to the left. Okay, last section. Okay, 1.9, last section. This is compound inequalities. So we have two things here. We have or, which is our union, and we have and, which is an intersection. And so when we have a union, we're looking for all of it. So anywhere there's graph is the answer. We have an intersection. Remember, that's where the only part that's the answer is where the two graphs overlap. So we'll just solve each of these and kind of see where it comes out. Here we're just going to add the 7 over first. So that leaves me 7x plus 7 minus 7 was good. And then less than 21. And then divide the 7 over and get x is less than 3. On this side I'll add that 3 over. So I get 2x is greater than negative 2, and then dividing the 2, I get x is greater than negative 1. So this one is an and. Let me get this drawn. Again, it doesn't have to be a fancy graph. Make sure you get negative 1 if you have to label it yourself, to the left, and positive 3 to the right, because that's where they really are on the number line. And then thinking about what this is going to look like, we're going to have the x's are, it's an and, so we want where we have both graphs. So x less than 3, I'll do in red. That would be here and going that way. You don't want to draw this for the test. I'll show you what you do want to draw, but this is just to explain it. X greater than negative 1 would be this. So your answer on the exam is the place where both of those graphs overlap, because it's an intersection. So just like when two roads intersect, that's the intersection right there. This right here is our answer. So you don't want to draw all that extra stuff. You just want to draw, if this is negative 1 and this is 3, open dot, the stuff in between, because that's the only part that's actually the solution set. For this or, I'll just solve these out. Plus 1, plus 1. So 3x plus, 3x is less than or equal to 9. Those cancel. And then dividing the 3, I have x is less than or equal to 3. And that's going to be or with this one, plus 5 on both sides. So I have 6x is greater than or equal to 9 and 5 would be 24. And then divide the 6. X is greater than or equal to 4. So if I do a little number line for that, there's 3, there's 4. X is less than or equal to 3, so that's going to be solid and going this way. X is greater than or equal to 4, so that's solid and going that way. And that's it. So for an or, it's just wherever you have graph, but for an and, it's where the graphs overlap. Okay, these are the last two. So this one's an and, so we're looking for the overlapping. And I have this example just to, again, remind you for like the 23rd time or something in this video that you have to flip the sign. And so while I have the green pen out, I'm just going to do that on both. So that's going to be x is greater than negative 4, and then and here the 2's would cancel. X is less than or equal to positive 2. So here we're going to throw our negative 4 and our 2. So the x's are greater than negative 4, no equals, so we want to use an open dot, and that would be going that way. X is less than or equal to negative or to positive 2, so that would be a solid dot, less than going that way. So you can see it's that region right in between those. And then this last one is what's called a continued inequality. It's the same thing as an and. It just is when this stuff is the same prompt, what it's less than and greater than, you can write it this way. So I'm going to rewrite it down here just a little bit bigger. That looks really bad. Let me come down here. And so if you think about what you would do if it was that third piece wasn't there, you'd add the 4 and divide the 2. It's the exact same thing, you just have to do it in 3 places instead of 2. So we'll add the 4 over. And that's going to go negative 2 is less than 2x is less than or equal to 14. And then next we would divide the 2, right? So we just do that same thing, we just have to do it everywhere. And we know what to do because we're getting the x by itself. So stripping everything off that is what's kind of driving my choices. So negative 1 less than or equal to x less than or equal to 7. And so that would look like negative 1 and 7. Both ends are solid, and the x is staying bigger than negative 1 but less than 7. So there's that same kind of in-between behavior. And that wraps up the Exam 1 review.